Let's see. All right. Well, let's see how they like this. Oh my, it's a box.
Yo. Ooh-wee, I'm glad I got this package. Oh, oh wow. Uh-oh, uh-oh. The box. Oh, ow. Ow. Ow, please stop. Oh, ow. Please, oh no, ow. Ah, ah, ah.
After seeing the mental anguish that poor test subject went through, I'm sure you'd like to see what the first iteration of the BDSM box was. Originally, our one servo motor was going to have a two-joint arm with the flail attached to the end of it. This had to be simplified eventually into just one single continuous arm, purely because the joint proved way too hard to build. Additionally, it used to be supplied off of just one big battery, but that had to be subbed out for two smaller batteries, one 6-volt and one 5-volt, or one 9-volt, one to supply the Arduino with power, and one just to supply the servo motors with power. Additionally, here you can see the IR sensor, the tilt sensor, and the motor. We found out that the tilt sensor was better placed on the side of the box so it could be more easily tripped. And additionally, we threw on a buzzer and a second servo motor into the final design, although the second servo motor has some problems. Here is the circuit diagram for this. We can see our tilt switch plugged into digital 13, into digital 11 we can see our DC, into 10 and 9 our two servo motors supplied by the external 6-volt power, and then at the bottom here we can see our buzzer plugged into digital pin 8. On the left side, we can see our IR sensor plugged into digital pin 3, all with the common ground running into this terminal right here. Here's part 1 of our flowchart describing the arming sequence of the BDSM box. Initially, it'll wait until the power button on the IR sensor is pressed. It'll then begin recording your password, check if your password is incorrect. If it is incorrect, it'll play the wrong password note, print wrong, and then send you back up here to begin recording your password again. If not, it'll toggle the activation variable, print correct, and send you on to the next part. The second part of the flowchart describes what happens after your password is checked. It'll check the activation variable and toggle it, either playing the activation noise or deactivation noises accordingly. If it was activated, it'll then begin reading the tilt switch until it reads high. Once it reaches high, it'll print go time, turn on the DC motor, which tightens the fishing line around the thief's hands. It'll then print line tight and play the go time song. Then the servo motors will pop out of the box and begin whipping the person's hands, actuating between 70 and either 110 or 50 degrees depending on the servo. It'll then let you go once it's whipped you 4 times, print get out of here, bring both the servos back into the box, deactivate the activation variable, play the deactivation sound, and reset. Here's the first chunk of our code where we show all of the included files as well as the tone pin, tilt pin, all of the IR variables, the password variables, the servo variables, and the activation variables, and just a simple iterating variable. In the setup here, we can see we start our serial monitor, start our IR sensor, set up our tone and tilt pins, set up both of our servos and our DC motor, and then set whatever our password is going to be, which for me is 2486. The first thing our code does is begin receiving from our IR sensor. If it receives a power button click, which is 69 seen right here, it'll print reading in chat, have some debounce time, and then it'll kick into some borrow code to check and record your password. Obviously, first it records 4 digits from your password and appends them into an array here. It'll then go on to check if your password is the same as the set passcode. If it is, you get booted right down here where the index is reset and begin passcode is also reset. It'll then change the activation variable, either playing activate or deactivate, depending on what the past state of activation was, and then you'll get kicked to the next chunk of code. If your password doesn't match the set password, your serial monitor will have wrong printed in it, and then the wrong tone will be played. This ends the borrowed code section. Once your box is activated, it will begin reading the tilt switch. Wait for it to get jostled a little bit. It'll then print go time, begin tightening the fishing line on the thief. Play the go time song, give you a couple seconds. It'll then print line tight and begin whipping your hands, actuating the servo motors 4 times. Once it's actuated those 4 times, you get kicked down to here, where we'll print get out of here, retract both the servos into the box, change the activation variable, play the deactivated tone, which is the next thing we're going to look at, and reset the top, obviously. Here's the deactivation by tone. It's just 2 frequencies decreasing, so it kind of sounds like dun dun. It's the wrong tone. It's just 2 low frequencies, just dun dun. Then we have our activation tone, which is the opposite of our deactivation tone. It goes dun dun and increases in pitch. Then our go time, which is the baseball organ theme, where it goes dun 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 dun, but it's a bit hard to hear in the video. And the last thing we have is our play song function. If I was going to do this again, I would change 3 things guaranteed. One would be the internal DC motor used to tension the cable. I found that it cannot provide enough torque to efficiently and consistently tighten the cable. It's pretty hit or miss. I would probably just replace with a little spring on an axle. The second thing I would replace with the servo motors. They're pretty finicky. I think it mostly comes from the power, as the motion of them moving often ends up unplugging the wires that attach them to their 6-volt power supply. Either having fully soldered wires for this or just replacing them with something simpler would probably help with that. And the last thing, I'd probably mount the IR sensor externally on the box. Currently, it doesn't get a lot of the readings that it should, and I think that's largely either due to IR radiation, which is probably a non-issue, or it just being blocked by the box and all the electronics inside of it.